Hello, today we're gonna talk about how to integrate a triple integral in 6 different ways. So let's start it. We have a region bounded by y equals x squared and z equals 0 and y plus 2z equals 4. So this is a solid. And we're gonna draw the 3 domains that's projected by this solid on each coordinate system. So step 1, draw 3 domains. So I have x, y coordinate, and I have y, z coordinate, and x, z coordinate. Then I'm gonna draw the graph for, since this is x and y, I have a nice parabola. And because we know z equals 0, when you plug this in, you get y equals 4. So you have a horizontal line that crosses our parabola. And also I'm gonna write down for the convenience later that this corresponds to x equals positive radical y, and that parabola on the left side or negative side, you have x equals negative radical y. Alright, next I have y and z coordinate, and I'm gonna use this line. So I have a y equals y plus 2z equals 4. I'm gonna set the independent variable to be y and dependent variable to be z. Then if you draw this, okay, we can set y equals 0 and z equals 2. So our z-intercept is 2. We can set z equals 0 and then we get y equals 4. And here is a nice linear line, a linear graph. And we know that z equals 0. So basically our y axis, and also you gotta notice that the y cannot be 0 because it's always positive, seeing that y equals x squared. So in other words, the minimum we can have is y equals 0. Y equals 0, actually that was z equals 0, and it's bounded by 4 minus y over 2. Okay, let me rewrite that. 2 minus, basically 2 minus y over 2 equals z. Okay. I'm also going to write down another rearranged equation in terms of z. So the other way you can write is y equal 4 minus 2z. So again, it's for convenience later. And finally, our xz coordinate, we have to combine the first equation and the third equation. Then we get x squared plus 2z equals 4. This is another parabola. So if I have z equals 0, I have either plus 2 or minus 2. And then when x equals 0, then I have one z-intercept at x equals 2. Because I know this is a parabola, and also if you rearrange this, you're gonna get an upside down. So for example, 2z 4 minus x squared. So you see the minus sign on that x squared. So it's gonna make it upside down or unhappy face. parabola. Okay. And as you know, z has to be 0. I'm gonna call this area, that projection as D1, domain 1, this to be domain 2, and the boundary region in xz coordinate to be D3. So we define 3 domain and we can visualize this to the next step. Next step is step 2, draw the solid. This is helpful if you want to visualize the surfaces. So surface equation, to be more precise, I have x, x, y, and z. Okay, so if you look at x, y, z coordinate, start from the origin, and then you have, okay, let me make it better. X, you have parabola that extend this way, and say that's 4. 1, 2, 3, 4, and then we're gonna have base that looks like this, and then I have y plus 2z equals 4. So try to visualize this in yz side only. So when you see this in the sideway, you're gonna see a triangle that's shown as in our D2 region, and the z-intercept has to be 2, it goes up that much, and it has to go down. Okay. And finally, to complete our picture, you gotta look at the xz coordinate. And then this is like, when you see from here, you're gonna see, oh, it's like another parabola from that view. So you get something like this, looking like that. Okay. I don't know what kind of shape this is, but you get the idea how. Okay. I'll clarify. So the region is a plane actually. This plane corresponds to our third equation, y plus 2z equals 4. So I'm gonna shade that with green. Okay. And that green, I'm gonna make it clear that, okay, so that corresponds to y plus 2z equals 4. Okay. Sometimes you might need 2 different versions, so I'm gonna write y equals 4 minus 2z, and then z equals z equals 4 minus y over 2. Okay, and for our, you see that surface there? It's kind of curved. This surface, and then there's another surface that we don't see here, but imagine it's like a transparent. You see that? This region. So you see my mouse cursor. Okay, that's the these both regions correspond to x equals y squared. In other words, we have an infinite cylinder of this parabola looking, but then it got truncated by our plane, the green surface plane you see, and also the z equals 0, our base plane. And so that's how it works. And this is the y equals x squared. Same for the one we don't see. And I'm gonna set these into 2 different, because later on this is gonna really help you. So okay, for this you get 1, but when you get the x equals, you get the 2 kind of version. So this radical 6 corresponds to what we see, the surface what we see, surface of what we see, and the one we don't see is x equals negative radical y. Okay? And finally, I'm going to also define that the base that's on which our solid stand equals 0. Okay? Having defined all this, we're going to move to the domain. So the range of the domain. So step 3. Write the domain intervals. Okay. We're going to get 3 domains accordingly from step 1. Okay. And let me start out with domain 1, the one I just declared. Domain 1. Okay, we're gonna start out with x, and each domain has 2 different versions, depending on which variable comes first. And looking at this, looks like positive 2 and negative 2 is crossed. Okay, and our y. Okay, remember that the first part of the domain has to be between constants. We have 2 and negative 2, and second part usually involves variables such as in this case you get y. It could be constant, but at most you can have one variable. So I have y between, well, looking at that, y is between y equals 4 and the x equals y equals x squared. You have x squared, and that's it. Well, you can also have, you can start out with y. Looking at this, y seems to be ranged from 0 to 4. Okay, 0 to 4. And our x, okay, this is when it comes very handy. X equals radical y. So I put the positive right minus left, or right function and the left function to be the left. And I have negative radical y. Okay. So I just did the one domain. Now let's go to the second domain. Our second domain, I'm gonna call it yz because that's what we did in step 1. Okay, so y ranges from, since y is the independent, it goes from 0 to 4, and z, okay, what's top here? Okay. Z equals 2 minus y over 2, and then z equals 0 is our bottom function. And then now this time we're gonna set the z to be first. Z, as you see, goes from 0 to 2. And then our y, okay, this is when it becomes handy again. I set 4 minus 2z, or you can rearrange that if you don't see it well. So it's gonna be 4 minus 2z. That's our right equation. Our left one is 0, y equals 0. Okay. And finally, our D3 region is going to involve x and z. Looks like it ranges from negative 2 to 2 for our x. And, oh, I didn't really define our third equation. Let me define that. Okay. This line, if you do this, you are supposed to get z equals 2 minus 2 minus x squared over 2, or if you rearrange this for our right equation, you're gonna get x equals radical 4 minus 2z, and you get x equals don't forget minus sign. Okay, minus radical 4 minus 2z. Okay, I'm kind of skipping a lot of steps on like how to rearrange and stuff. That's like algebra 1, so please bear in mind you should try them when you do this problem. Okay, so x can range from -2 to 2, and our z ranges from, okay, again we have z equals 0, and then 2 minus x squared over 2 is that top curve. Okay, for our last one, okay, this time I'm gonna have z is between 0 and 2, and finally the x, you see the right function, radical 4 minus 2z, and negative radical 4 minus 2z. I know it's kind of hard to see. Let me rewrite that. Yeah. Okay. So negative radical 4 minus 2z, positive 4 minus 2z. There we go. So once you get these three, now our step 4 is to create the E interval, meaning the solid intervals. Alright, let me scroll down. And our step 2 will be very helpful to visualize our third variable intervals. So step 4, let me state that. Write the solid interval. We're gonna get 6 of them, just like we had 6 from the domain. So, okay. First, you can copy down. When you have tests, maybe you could skip the step 3 and then just all combine in step 4. But here, I'm just gonna guide you all steps, step by step. Okay. You can copy down the domain up to this point. Now the question is, how do we define the z? Well, now you really have to look at step 2. Looking at this top surface, okay, top surface minus the bottom surface. In other words, we know for sure z equals 0 is the lowest surface, the bottom surface we see. We also have to see the top surface, the limit. And since this is in terms of, let's see, x and y, we have to choose, okay, z equals 4 minus y over 2. Let me simplify it as 2 minus y over 2. Okay, you have to choose this one for this particular set. Okay, now you don't have to worry about, since, okay, these two I'm gonna specify for you is d1. So in other words, since our last variable z just copied again, except we have different domain for our first two variables, so just copy from our second. You see here, I'm gonna say this second and first, third. Okay, let me use different color. This is good. 1, 2, 3, 4, 5, and 6. Okay, so I'm moving to second one. Just copy it. And also copy the z. Okay. Alright, and then we're gonna go to D2, our domain, second domain. And again, just copy it from our step 3 up to the second variable. So our first variable is y, and then second variable is z. So our third variable must be x. Okay, so now we go back to the step 2 again and see where the try to see the x surface is. So in other words, what pops up to the x minus what goes behind the x. I'm talking about the purple surface here. So looking at that, since it's in terms of y, and I have to write negative y. Okay, that's the one that we don't see again, and one we see is the more positive. So I'm gonna put radical y, and we're done with that. Then moving on, you copy down the fourth domain. And just copy down the one you see in the third one for our third variable. Alright. Almost there. D3. Okay, D3. Okay, this is corresponding to our fifth and sixth. Copy down. Okay, we have to do the third one. Now our unknown variable, I'm sorry, the third variable is y. Let me see. Yeah. You know what? I should have used different color, but oh well. Y. Okay. Looking at this, now this is a tricky one. That green surface you see, that plane, is more positive or more toward the right side of the y than that purple surface. Okay, so that gives us the change in height in y. In other words, we have to put the green one on the right side and the purple one on the left side. I'm gonna use different color so you can get confused. Alright. So, but we don't need two versions of the y equals x squared. It's just y equals x squared, because now this equation actually goes around the surface we also don't see from our perspective, and our green one should be in terms of y, and I defined it above here. Okay, if you see it, I defined it here 4 minus 2z. Now that gotta go into our this region, 4 minus 2z. And that's it. You just copied our sixth domain, 0 to z is between 0 and 2, and x is between negative 4 minus 2z and then just copy that down. Alright. Now from here, it's very simple. All you have to do is, copy down the upper bound and lower and upper bound accordingly. It's very easy. Once you finish step 4, it's very neat. Okay, let's start with the first one. Okay, it goes from -2. Our x goes from -2 to 2, and then x squared to 4, and then 0 to 2 minus y over 2. Okay, and then we are given certain function. And now here's a tricky one. You don't write like dx, dy, dz. That's no. You gotta go this way when you write the dx, dy, dz. So since you see z at the, okay, start with a dz, and then dy, and then dx. Okay. Alright, next one, we write the integral, and y is between 0 and 4, and negative radical y. So when we write the limit, so make sure you go, so our limit, you write that, our dx, dy, dz, just go backward. I'll say these. Okay. It could be dx, dy, dz. So again, limit goes to the right, these go to the left. So since I'm writing the limit, let me write all this in red. 4 to 6. Alright, you know why it's kinda bad. So let me rewrite that. We have function, and like I said, okay, I see z first, y, and then x. Z, x, y. dz, dx, dy. Third one. Okay, I see around 0 to 4. 0 to 2 minus y over 2, and then negative y to radical negative y to positive radical y, and okay, we're going backward this time. dx, dz, dy, x, y, x, z, y, dx, dz, dy. Alright. Alright, I see 0 to 2, 0 to 4 minus 2z. Alright, after copying that, I see dx, dy, dz. 2 more and we're done. Okay, I see negative 2 and 2. And then I see 0 to 2 minus x squared over 2. And I see x squared and 4 minus 2z. So x squared and 4 minus 2z. Okay, I see y, z, and x. Okay, again, y, z, x, dy, dz, dx. Almost done. Okay, from 0 to 2, and this is our last one, our sixth one. And then this is the second integral. I'm sorry. The second integral is between these two functions. So I get negative 4 minus 2z and 4 minus 2z. And our last one goes from x squared to 4 minus 2z. Okay, I see y, x, z, y, x, z, so dy, dx, dz. Okay. Well, that's it. So hopefully this was helpful to most of you, and I'll post more triple integral, like probably like the application, like a center of mass. So I'll see you guys next time. Thanks for watching.